Hello everyone, I am Deep. Welcome to ChemE-Shiksha. This is the very first video lecture of our channel ChemE-Shiksha, and the first topic of this channel is pump, which is the most important and fundamental topic of chemical engineering. Whether you are going for any job interview in core chemical engineering company or any consultancy company, pump is the very important topic for you because you will be asked question from this topic. So let's deep dive into this topic. So first, what is pump? Pump, we know that pump is a hydraulic machine which converts the mechanical energy into hydraulic energy. Hydraulic energy means the pressure energy. So pump is nothing but a hydraulic machine. Why hydraulic machine? Because it will convert the mechanical energy which is done by the motor into hydraulic energy, basically the pressure energy. Pumping means the static lift of the fluid. So generally with pump we handle liquid. So pumping, this word means actually static lift of any fluid. You can tell vertically static lift of the fluid. So pump, working principle of pump is forced vortex flow. So there are actually two types of vortex motion. One is called the free vortex motion, another one is the forced vortex motion. What is the difference between these free and forced vortex motion? The free vortex motion, in case of free vortex motion, there is no external torque or external energy. Okay, without any external torque or energy, the fluid will rotate under the certain energy which is previously given to it. But in case of forced vortex motion, some external energy or torque will be continuously required to rotate the fluid. The pump develops static pressure in the fluid by virtue of which the fluid can be distributed in the pipe system or it can be lifted up. So as I told you that pumping means the static lift of fluid. When pump is required, we want to lift the fluid vertically upward. That's why pump is required, because we know any fluid, it actually flows from a higher altitude to a lower altitude or higher height to a lower height. So from the lower height to higher height, if we have to transfer the fluid, then pump is required. So pumping means actually the static lift of fluid, which is I am telling again and again. So pump develops static pressure in the fluid by virtue of which fluid can be distributed in the pipe system or it can be lifted up. Now the types of pump. There are basically two major types of pump. One is positive displacement pump, another one is dynamic pump. Now positive displacement pump are of two types, reciprocating pump and rotary pump. Reciprocating pump can be of three types like piston pump, plunger pump or diaphragm pump. And rotary pump are five types of rotary pump are there, like lobe, vane pump, peristaltic pump, screw pump, gear pump. Okay, and the dynamic or rotodynamic pump, there are three types of dynamic pump: centrifugal pump, which is actually the radial pump, axial pump, and mixed type of pump. So we will be dealing with all these kind of pump in the later video. So these are the types of pump. Now this is a picture where centrifugal pump is shown over here. So you can see this is the sump. Sump means from where we want to lift the fluid to the overhead tank. So this is the overhead tank. This is the sump. So from this sump we want to lift the fluid to this overhead tank via this centrifugal pump. So see, there are some parts of this pump, like this is the impeller, this is the eye of the impeller. Okay, so this is the eye of the impeller where the fluid will be sucked So I'll be telling this working principle in the next video. So just see over here that this is the eye of the impeller, this is the impeller. Okay, so when the shaft will be moving, this impeller will be also moving, and from this sump via this foot valve, the fluid will be moving towards this. So why this strainer? Strainer is actually required to remove any debris material if it is present in the fluid of the sump, so that it cannot damage the main body of the pump. So this side is called the suction side. So this is the suction pipe, and this side is the delivery side. So delivery pipe, delivery valve, delivery flange, you can see. Okay. Now let us talk about different types of head, like the suction head, discharge head, static lift, and net head. What is the suction head? The vertical distance between the pump center line and the surface of the liquid on the suction side. See, this is the center line of the pump, and this is the free surface of the suction side. Okay, so this is the suction head. Okay, HS. So the vertical distance between the pump center line, this is the pump center line, and the surface of the liquid. Okay, this is the surface of the liquid in the sump. So this vertical distance, this is called the suction head. If the source is above the pump, it is called positive suction head. If below, like underground tank, it is called the suction lift. Okay, so if your source is above the pump, then it is called the positive suction head, and if it is below the pump, then it is called the suction lift. Now what about the discharge head? The vertical height between the pump center line and the point of discharge. So this is the point of discharge. We can see this is the point of discharge, and this is the center line of the pump. So this vertical distance is called the delivery head, or the discharge head. This discharge head represents the energy needed to push the fluid to the required height or pressure after pumping. So the discharge head actually represents the energy needed to push the fluid to the required height or pressure after pumping. Now what about the static lift? The vertical distance between the liquid surface in the source or the sump and the pump outlet defines the static lift. So what is actually we are doing? We are lifting the fluid from this sump, from this free surface to this free surface. So this total height is actually the static lift, because the pump is actually lifting the fluid from this surface to this surface. So this is the static lift. So the vertical distance between the liquid surface in the source or the sump and the pump outlet defines the static lift, representing the potential energy the pump needs to overcome. So this is the actual potential energy pump need to overcome. But there is another thing actually, that is the frictional losses. Never forget about the frictional losses, because when the liquid will enter in this suction pipe, there will be some inlet loss. Then the fluid will flow in this suction pipe, there will be another frictional loss. In this delivery pipe, there will be another frictional loss, and when this fluid will exit from this delivery pipe, there will be another loss, which is called the exit loss. So there are different kind of head losses are there, like frictional loss, inlet loss, exit loss. So the total head developed by this pump is actually the summation of this all of the head losses plus this static lift. This can be proved. Okay, so the net head developed by the pump is actually the static head or static lift plus the sum of all the frictional losses. See, this is the picture. Okay, so this is the sump. From here we are lifting the fluid to this free surface. from this surface A to surface F. So in this graph of head versus flow path, we can see that from A to B there is one head loss. Why this head loss? This is the inlet head loss. Why this is? See, this A surface is above this surface B. So the head of this A is more than this B, right? So HA, if the head of this point A is HA and head of this point B is HB, so HA is more than HB. So this loss is actually the inlet loss. Then from B to point B to point C, there will be another loss because of this bend. Okay, these flanges are there, and also some skin frictional loss will be there. So because of this, there will be another frictional loss that is termed as HF1. So B to C, there is HF1. Now from C to D, this is actually pump is doing. Okay, from C to D, this is the actual lift. This is the static head developed by the pump. Sorry, from C to D, this is the pump is increasing. This is the total head developed by this pump. And then from D to E, this there is another loss. D to E, there is another frictional loss because of this bending, and there are skin frictional losses are there. So that's why there is another loss, that is HF2. And then from E to F, there is another loss, that is the exit loss, that is termed as HE, exit head loss. So this is the curve of head versus flow path. So as I told you that this can be proved that the total head developed by the pump is actually the summation of the static lift and the sum of all the frictional losses. So see this, at this point A, if head is HA, and at this point F, the head is HA plus HS. HS is the static lift by the pump. As I told you, what is static lift? That is the vertical distance from the free surface of the sump to the free surface of the overhead tank. So this is the static lift, HS. So the total head of free surface of higher reservoir at this point F is HS plus HA. Now between this point A and point C, we can write HA is equals to P1 by rho g plus V1 square by 2g plus Z1 plus H in plus HF1. From the modified Bernoulli's principle, we can write it that the head at this point A is actually HA. So HA is equals to the head at this point C, that is P1 by rho g, plus there will be velocity of the fluid V1, so V1 square by 2g plus Z1 is the height potential, plus H in, that is the inlet head loss, plus HF1, that is the frictional head loss. So you can write that P1 by rho g plus V1 square by 2g plus Z1 is equals to HA minus H in minus HF1. Similarly, from between this point D and point F, we can write P2 by rho g plus V2 square by 2g plus Z2, that is the head at this point D, is equals to head at this point F, that is HS plus HA plus HF2 plus HE, because there are some losses. So head at the inlet of the pump H1, that is P1 by rho g plus V1 square by 2g plus Z1, and at the outlet of the pump head is P2 by rho g plus V2 square by 2g plus Z2. So the net head developed by this pump is H2 minus H1, that is this value minus this value, and we can see that P2 by rho g plus V2 square by 2g plus Z2 is equals to HS plus HA plus HF2 plus HE, that is written over here. And this P1 by rho g plus V1 square by 2g plus Z1, that is the H1, is equals to actually HA minus H in minus HF1, this value. So from here we can write that the net head developed by this pump H2 minus H1 is equals to the static lift, because see H1 HA will be cancelled out, so we have only HS this term plus HF2 plus HE plus H in plus HF1, that is all summation of all the head losses. So net head developed by this pump H2 minus H1 is equals to HS, the static lift, plus sum of all the head losses. So yeah, this is the end of this video. Join our community. If you like this video, please hit the like button, subscribe my channel and share this video to all of your friends and be a part of a growing network of future ready chemical engineers. Thank you all for seeing this video and see you in the next video. Thank you.